My name is Jehmal Nurridin. I am National Director of Enterprise Network Design for Windstream. Carl gave a brief overview of Windstream earlier today. My ultimate responsibility is network design, implementation of those designs, and then ongoing support for the customers from an engineering perspective for Windstream's enterprise customers, which are in many instances, many of the higher or top healthcare companies in the country. I'm going to go through a number of things today specific to the Windstream model of how we go about supporting much of the technologies that you guys have heard about today. Telemedicine is, it's always interesting to me. We see this information, we sit in these type of forums and we take in the information specific to or through the lens of what our priorities are. Based on whatever our job responsibilities are, what have you. And much of what I'm hearing, all I'm listening to and what I'm seeing, the demo and the information is, telemedicine being so key in the future for healthcare and the providers. My responsibility is to make sure that the network that connects the user and the healthcare professional is up to par, and that it works and that it continues to work. Otherwise, this technology, this function, this feature, is useless. And that's functionally what my responsibility and my team's responsibility is and what my organization does. Yes. So I'm going to go through a brief company overview of what Windstream does, who we are, where we are. I'm going to talk to the tools that we use. There's a lot of products and services and marketing names and things along the line for many of these technologies. I'm going to talk to how they play a role ultimately in the day-to-day function of healthcare environments with telemedicine, with WAN infrastructure and architecture, voice connectivity between locations, internet, things along that line. I'm also going to talk to what many of the challenges are that we're seeing within the healthcare market with many of the providers that we work with. Many of our customers, UPMC, Memorial Sloan Kettering, Queens Long Island Medical, I can rattle them off. These are all organizations that I've worked with and my teams have worked with to help design these sort of networks to support many of the technologies and services that you look to provide to your patients. We'll talk to what many of those other challenges may be specific to inter-office connectivity, network security, ensuring that you are HIPAA compliant, ensuring that you meet the Sarbanes-Oxley requirements, and that the information is not just protected as to what you receive into the network, but how you control and protect the information that goes out of your network. Then we'll talk to network reliability and business continuity. In many instances, we have to make sure that these services, once they're in place, if there's a challenge or a problem, how we keep that network working even through the problems that may come up, and then how we respond to the challenges that come up. So that's essentially what we'll go through. I know that there is going to be a panel discussion and a lot of Q&A at the end, but if you have questions as we go through it, please do not hesitate to pose them. So as Carl had mentioned earlier, Windstream, we are a Fortune 500 company. We provide advanced communication services for all sorts of businesses, not just healthcare, but in any other vertical as well. We have, over 450,000 business customers. We support many of the Fortune 500 companies as it is. And I can go through, I'm not going to read each of these slides, but we are a formidable player in the business communications market. And effectively, that's where our target functions have been. Aside from this looking like North America got a bad case of varicose veins and measles, this is our network architecture. We have POPs throughout the country. We have central offices. We have fiber that is all entrenched within the network, and this is effectively a private IP backbone for us. This also represents all of our ingress and egress points to the internet, so this also defines not just our private architecture, but where we hand off to many of the other public points of presence. But effectively, this represents our private IP network, which, as you can see, is national. We also, which isn't depicted here, have an international presence and can provide services internationally as well, but this primarily is our focus today. The Toolbox. I referenced many of the different technology names or products and services that can be offered, and they span from data solutions to voice solutions, internet services, data center services, whether it's cloud or just colo with power and cooling. But effectively, as the need arises, when we need to meet the need for our customers, whatever those needs are, whether it's telemedicine, whether it's security, whatever it may be, we choose and pick based on what we have available to us to support that need. So these are effectively all of the services and products that we can offer you, but really it's just a toolbox that we use to design the networks that support the services that you provide to your customers, to your patients. So with what drives the needs within the communications network for healthcare providers, it's going to be inter-office connectivity. It is the basic framework for any telemedicine or other WAN architecture service. In order to communicate from one location to another, whether you're using the internet, whether you're using an IP backbone like an MPLS, whether you're using point-to-points, there's so many different ways of communicating from site to site. The drivers for that inter-office communication are going to be, how do you provide services to your patients? Can you support telemedicine with the nature of your WAN architecture today? Can you prioritize the number of different types of applications that you're sending between locations? You have telemedicine, you have voice services, basic telephone calling that you're doing. You have internet services, folks that are browsing or need to do research. You're also pushing other types of information between locations, especially in the healthcare market. CT scans, radiology type imaging, EMR. As all of these emerging requirements and technologies are pushed between locations for any network that is defined by multiple locations, you have to have a WAN architecture that can support all of these things at once, as well as prioritize and ensure that each of the applications that are being sent between locations gets the priority necessary so functionally it meets the need that it was designed to do. As an example, with telemedicine, if you can't see or you can't have an ideal image, a crystal clear image of what you're looking at, it's not beneficial to either user. So that's key, and our WAN networks have to support those sort of applications. So that's effectively another driver. Other challenges within the healthcare market that we see, and very specifically, we worked with Select Medical or UPMC for this sort of thing, was rapid deployment. In many instances, you have organizations that have many types of sites, whether it's a clinic, a doctor's office, a hospital with a trauma center, a hospital with a medevac center, data centers, hub sites. Each of them have to have a particular method of deploying connectivity at that location and making sure that it's consistent to each other type of site like that. Otherwise, you have a hodgepodge of communications networks or equipment there, different types of PBXs, different types of switches, different types of firewalls, different types of routers. And with that mismatch of technologies and mismatch of architecture, you get poor performance within that network. So rapid deployment and consistent deployment was a very key component to WAN architectures for organizations like UPMC, who have 500 locations and partners throughout the country, or Select Medical, who have over 1,000 locations and partners throughout the country. When you come into their umbrella, if you don't have the ability effectively to communicate consistently using these sorts of technologies like telemedicine, it becomes moot. It's not beneficial to the partner to come into that organization. Another component specific to these sorts of networks would be QoS. When you talk about the different types of technologies and the different types of services that need to be sent between locations, whether it's telemedicine, whether it's voice, whether it's email, whether it's EMR. Whether it's EMR. All of these things require a certain amount of bandwidth, and you have to be able to manage the bandwidth at each of your locations to ensure you have the right amount and that you're effectively using what's there. You don't want to oversubscribe or over-deliver services and have the user paying for something that isn't necessarily required given the volume of work that they anticipate on a day-to-day basis. But at the same time, you have to make sure you have enough bandwidth to support all of the applications as they're running simultaneously. Imagine if you're on a phone call and a telemedicine call is initiated, and suddenly your phone call drops, or one of the two of those applications gets poor quality. It defeats the purpose, and effectively what QoS does is supports those dynamic applications throughout that bandwidth to ensure each of them has the bandwidth necessary to perform optimally, so nothing is compromised in that regard. If and when each of the applications either initiates or ceases for other things to go, QoS can reallocate that bandwidth that's already there to other sorts of applications. You know, you think about all of the other things that go on in a doctor's office. You've got wireless devices, PDAs. There's so many other functional devices that use that same bandwidth that's at a location. You have to make sure that there's something as a traffic cop to ensure the applications get what they need. There's a lot of studies and formulas that go into the process to drive down how much bandwidth is necessary and allocated to each type of technology. And we can go through those nuts and bolts if you like, but effectively this is a key component to a private WAN architecture and something that you don't get if you push this traffic just across the web. Security. When it comes to a WAN architecture, the difference between having a private IP network and a internet network that you're pushing your traffic between locations just using the World Wide Web, you have to be able to secure that information. When it comes to some of the requirements and standards like HIPAA, like Sarbanes-Oxley and other sorts of parameters along those lines, in order to secure a WAN architecture to meet those needs, you can either do it with hardware that's on the prem, firewalls and IDPS types of devices that do intrusion detection, gateways for antiviruses and things along that line, or you can also deploy those sorts of initiatives in the cloud. Either way, with EMR being such a prevalent function as we go forward, you have to secure this information, and it's not just a matter of attacks into your network, it's also a matter of what you control that goes outside of your network. So having the right type of security appliance or initiative in place ensures that you can control what information is leaving your network, because you have to meet the needs of what the customers or what HIPAA compliance requires. This includes encryption and things along that line for the transport across the WAN and then out to the egress to the web. Something that I wanted to point out, because I think it's key, especially when you talk about mitigating risk, and mitigating threats that are either coming into your network or leaving your network and where it takes place. If you're using a private network to do it, and you have an internet connection also at that location, you could effectively put a firewall at your site or at a location and have it do that protection for what comes in and out. But keep in mind, a firewall at your location is stopping the threat at your door. If it has to stop the threat at your door, it's effectively using resources and bandwidth for that same connection that you would typically use to send traffic to and from locations. So it can be effective, but at the same time, it's going to drain resources and available bandwidth from the site that should remain functional. So if you get a denial of service attack or a DDoS attack, it could be stopped at your firewall, but it's still going to cripple the connection. The difference there is if you stop the connection, let's say this is a virus, but it's a zombie, because those are cool nowadays. If you stop the connection, or if you stop the threat here at the edge of the web before it actually reaches your private IP network, we effectively are stopping the threat before it ever gets to your site and prevents taxing of the resources that would typically be used to send traffic between locations, whether that's telemedicine, whether that's EMR, whether that's voice over IP, or just general voice telephone calls, whether that's email, any other types of applications that should be spun around the private IP network just between locations do not get impeded while the security protecting all things from the web is done in the cloud. So this effectively is what this slide talks to, and it's a key component, especially when you talk about having users come in from the web, understanding that you're going to have gateways, you're going to have users that are coming in from the web that are patients that want to come in via telemedicine. They're initiating contact to you from any internet connection USA. You know, this could be wireless, this could be cable at home, whatever they're using, they're coming in. You don't know what their security is, and if it's up to you to block it all, it's going to tax your WAN resources, which effectively impact your business. So it's an argument to be made for doing it at the edge of the cloud, and that's effectively what this talks to. That's us stopping the zombie. So, business continuity. It could be Cuisinart or Tefal, it could be Eureka or Kirby, it could be Toyota, Chevy, Mercedes, PC, Mac. I don't care what you buy, they sell you a warranty because the technology is fallible. In our business, it's the same, but we aren't going to sell you a warranty. You need to have your connectivity up and working at all times. Cisco, Juniper, Adtran, Lucent, it breaks. It's possible. And we have to have some measure of backup, especially in the healthcare environment. You know, I have these conversations with, especially the hospitals that have the trauma centers and have the medevac centers. Can you imagine having a hospital that doesn't have a backup communication when their power goes down or because someone takes out a fiber tower a mile away? In those scenarios, if there isn't a backup, if there isn't an alternative plan for communications, it has a tremendous impact, not just on the business, but on the patients that are there. It has to have some sort of backup for mission critical applications. That's effectively what this talks to. So in our business, that warranty that you get for whatever you're purchasing is a backup plan. And with our customers, what we've done, and I'm going to talk from a very basic scale, and in this instance I have a very small scale, and the next slide we'll talk to a very large scale of redundancy. But effectively, in our business, we look to, and this is something we did with both Queens Long Island Medical, UPMC, and Select. We had to have them categorize their locations. Again, you've got clinics, doctor's offices, hospitals that are equipped in different manners, data centers, hubs. Categorize your locations, and let's talk about the acceptable risk for outage. If you lose a clinic and you lose connectivity at that clinic, primary connectivity is going to have a finite impact versus if you lose connectivity at a data center that feeds all of your locations. You know, so we have to look at it from that manner because obviously these warranties cost money. So at a small scale, any location, we can establish what the primary connectivity is going to be, whether that's T1, Ethernet, fiber, whatever it is, that being your primary connectivity, and then what is your backup? Does it make sense to have something that's riding the same path that your T1 or your primary connection is? Probably not. So let's look at something alternate that won't be impacted by what typically would impact the primary connection. At a low end, we could look at a wireless backup. And that's what this really depicts, is in the event that something takes the primary connection down to the customer site, imagine that all of these things that sit behind this router are all of the functions that run your business. This wireless connection would kick in and take over primary connectivity until the primary, or take over connectivity to whatever resources are throughout the network until the primary connection comes back up. Something else that comes into play in these sort of scenarios is not just do you have a primary and a backup path, but what is the time frame for that failover from the primary to the backup? Is it real time, meaning if you know, and the sensitivity of many of the applications that are being run on a day-to-day, minute-to-minute basis don't tolerate an outage backup plan that kicks over in 30 minutes or a backup plan that kicks over in 30 seconds. Many of these applications, if it's not transitioned within milliseconds, it drops the call. Imagine if you're in the process of sending a CT scan, or if you're in the process of doing a consultation via telemedicine, and you lose that connection with that customer, or with that patient. Depending on the nature of that conversation, that could be traumatic for both involved. So we look at not just what is the primary and what is the backup, but what is the time frame for that primary to backup transition and back at a small scale and then also at a larger scale. So if this slide depicts just a backup connection to whatever the primary was at a smaller location, customer location, doctor's office, clinic, what have you. This slide would depict the grandiose scale of the same similar premise. In this instance, we've got not just a backup connection to a customer site here, but we've also got a data center. In this instance, everything that's at this customer location is also replicated at the data center. So if there's a hub and spoke environment, or the resources that this site is trying to communicate with throughout the network are located at site B, but in the event that connectivity to site B is interrupted, this location can still reach resources that are here by communicating with the data center, or vice versa. This also can have redundancy built in for voice. So in the event that you lose dial tone, you can still make and receive phone calls as though there was no outage. And it can also replicate what was missed during the duration of that outage. So let's say in a data center environment, primary connection goes down, you're doing real-time replication to the cloud for the types of EMR and other things that, transaction records that you're performing on a day-to-day basis, even during the outage. In the event that the connection goes down, you still need that information replicated. You still need record of what has been taking place based on the duration of the outage. That could be minutes, that could be hours. In some instances, it could be days. When we had Katrina, there were central offices that were lost right here in the city, flooded. What happens in those instances where the whole office is down? People are still getting sick, there are still injuries, you still have to process transactions. That has to be replicated, it has to be captured. We were able to do that, and we were one of the few carriers that were able to do it because of the architecture and the nature of these sort of environments. So again, this is high level and larger scale redundancy, but something like this gets put in place for a data center, or something like this gets put in place for a hospital. Larger scale, more connectivity, higher bandwidth, in meeting the need of the day-to-day transactions that they perform. Last, we talked about deployment, we've talked about inter-office connectivity, we've talked about managing the demands of many of these applications from a bandwidth perspective. We've talked about prioritizing that traffic so you're not having one application impede on another application. Lastly, how do we respond to these situations that take place? How do we respond to outages? How do we respond to our customers when things are going well and when things aren't going well? Within the Windstream architecture and network, we've got 6 NOCs. Each NOC is manned 24/7. We also have proactive monitoring. Is something that we do with all of our network connections. It's also something that we can do down to the router, down to the switch. Even if you want us monitoring devices behind the router, we can monitor that to identify if and when there's a threat, a problem with the connectivity, or if it's not performing at optimal specs. We also have our NOCs geodiverse. So God forbid if we're in a smoking crater situation where something has happened and we lost all connectivity and all of the people there as well, we've got 5 others, and we have them geodiverse that way for a reason, to ensure that we can support you in the event that we have to deal with first responders and many of the other catastrophic events that can take place just because the threat exists. All of these things are done effectively to make sure that we support our customers because we understand the nature of their business and the demands of their business. And if we are not responsive to our customers, we can't expect our customers to rely on us to support them in any of the needs that they have.